Hello everybody, this is Peter Frey from Platform9 Systems. Today I'm going to spend a few minutes and talk to you about Platform9's advanced networking options for the 5G world. Okay, so what we do as part of the automated 5G stack and what I've already done in the environment that I'm about to show you is I have leveraged Platform9's managed metal to deploy 3 servers using Pixie Boot. These servers have booted into a CentOS 7 environment, right? That kicked off a cloud initialization script that automated the deployment of Kubernetes. And for the purposes of this video, we're going to focus on this third box up where I'm going to show you how to deploy some of our advanced networking services, specifically around 5G and our SRIOV Multis deployment. Okay, so Platform9, we do leverage the CNI model. We will have a Calico interface on our box as well as a Multis deployed. Multis will allow us to have a second CNI, and it will be SRIOV. And we're going to attach that to our virtual functions sitting on the servers that we're about to play with. And from there, so what this is really going to look like is we're going to have a pod. It's going to have 2 network interfaces inside of that. ETH0 inside of the pod is going to be my Calico default interface, where primary communications for the pod will happen on Calico. But then I'll have a net 0 interface as well that will be directly plumbed to one of the virtual functions on my SRIOV enabled network interface card. And we're going to do this from scratch, so you'll see everything from the ground up other than the creation of the Kubernetes cluster. Let me step out of this. And so what we've got here, as you can see, I've got a Kubernetes cluster deployed. It's called MSK803. High-level CPU utilization, memory, and stats about this. It's running Kubernetes 1.18.10. And what I wanted to show you was that there are 3 servers inside of here. The MS01 server, this is my master node. He's the .207 box. We have a 205 box and a 203 box from an IP address perspective. These servers are supporting my 5G and my SRIOV implementation. So from here, I'm just going to pull this off my screen, and I'm going to show you those same boxes in this window here. So I've already did a kubectl get nodes. You can see that I've got the 3 boxes that I just described to you. And if I do kubectl get pods, you'll notice that I have just my Calico interface, core DNS, metric server dashboards, kind of standard stuff that we deploy inside of a Kubernetes environment. I had also deployed this Kubernetes cluster with Platform9 with our Luigi system already deployed. So that means this guy is ready to, Luigi is the code name for our advanced networking operator that will allow us to deploy with SRIOV. So without further ado, I have a number of YAML files here that the Luigi operator that can be deployed by hand, but I deployed it through our UI. So I'm going to start here at number 2, and I will do kubectl apply -f2, right? And this is really just configuring our network plumber. If I VI the 2 interface, all this is doing is applying network plugins to my environment. So it's going to deploy Platform9's host plumber, Platform9's node feature discovery, Multis, and whereabouts for IP address management. So host plumber is a component that is going to allow us to discover the underlying whether or not the NIC supports SRIOV or not, right? Things like that. And node feature discovery, they work together to be able to allow us to do that inside of our Kubernetes cluster. Okay, and then I'm going to do a kubectl apply -f, and I'm going to go to number 3 here. This is our host network template for SRIOV. I've applied that. I'll VI that guy to show you what that looks like. These are all simple YAML files, right? So we have multiple interfaces in these boxes that I've deployed to, ETH0 and ETH1, right? And then I wanted to create 20 virtual functions on each of those network cards, and I want to use the IXGBEVF driver. That's the Intel driver for SRIOV. And so if the host plumber discovered that the worker node had network cards that were capable of SRIOV, then this network SRIOV capable flag will be set to true, and it'll apply these configs to that environment. Okay. Okay, now I'll do a kubectl apply -f3. This is the host network template. Oops, we need to do 4 now. Okay, so we'll do number 4. It's doing that, creates a config map, and we'll look at 4. Literally, this is a filter for us to be able to create the PF names on the physical, not the physical function, but the virtual functions. So inside of those boxes, we have inside of Kubernetes we have a resource name called SRIOV kernel 0. The Ethernet names are going to be named ETH0 and then a number 0 through 19 for the 20 different resources that we're creating on each one of these interfaces. And then you can see the driver again. Here is the Intel driver for SRIOV. Alright, now kubectl apply 5, which is our attached network definitions, and I'll VI that. Okay, this is where we define that, hey, we are going to do an SRIOV NIC. I'm running on a very specific VLAN off of those network interface cards, and whereabouts is going to do IP address management for those network interfaces, and we're going to be on the 10.128.197 network. We're going to be in an IP address range between 20 and 49. Okay, almost done here. 6 network plugins. Okay, oops, kubectl applied. Network plugins. VI6. Okay, this is the same network plugins that we used before with host plumber, node feature discovery, multis, and whereabouts. But we also have included SRIOV is turned on now. Okay, and then if I ls here, my last file here is 7, which is going to deploy a deployment, and oops. We'll deploy this deployment. Okay, what this is going to do is deploy some pods that will consume those SRIOV network interface cards. So if I do a kgpo-a, we can see I've got a whole bunch of other host plumbers running on here now. You can see Multis is running on this box. I have the SRIOV CNI running in this box. And then you can see that I've got this SRIOV kernel deployment. So we're going to grab this top one here, and what I'm going to do is I'm going to SSH into that kubectl exec-it into that pod. We're going to run a shell. Okay, if I look at this box now, I can do IPA here, and you'll see I've got a net 1 interface and a net 2. We can see that they both are on the same network IP address from the whereabouts config that we showed you a second ago. Alright, so I'm going to copy this 21 IP address here, and we're going to talk to it in just a second. So now I'm going to just select the second one here, and I'll do a kubectl exec into this guy. Okay, so now we're on that other pod, and I'm just going to ping across to nope, not that guy, to the 128, that guy, ping, and now we're demonstrating east-west traffic across my SRIOV interfaces in this box. Okay, so quickly I'll exit out of there, and then what I want to do is kubectl get nodes, so I can capture one of the names here, and then I'll do a kubectl kubectl describe node on one of my workers. What's kind of cool here is the first thing you can see is that I am now consuming four resources. We've requested, and we have limits of 4 of the SRIV kernel 0, which is that SRIV interface that we deployed. And then you'll see also here, if I scroll up a little bit, I have capacity of 40. There's 2 network cards on there. And I have allocatable of 40. I'll show you that too. Right here, allocatable 40 there. Okay, so that's kind of cool that we have a capacity of 40. We have 2 network cards, each with 20 virtual functions defined. I've defined some pods that communicate across the SRIV interface. These pods are aligned along NUMA boundaries with the network card, so we get the lowest possible latency of communications from, one pod to the next pod on east-west pad traffic or inbound at line speed directly to those pods, leveraging SRIV. So that's my demo for today. Thank you, and look forward to talking to you soon.